Okay, today we're going to show a demonstration on how to measure lung volume using a spirometer. So this is a spirometer unit. So it comes with a recording bell. This one is the recording bell, and one drum filling with water, and also some oxygen or atmospheric air is actually locked inside here. So we are going to the subject will be breathing using this outlet here. So it will be a closed circuit whereby the nose will be closed, and during the inspiration and expiration, during the breathing, the subject will consume oxygen from here, okay, goes to the lung, and the carbon dioxide will go inside here, okay, through the soda line, absorb carbon dioxide and also moisture, and it will go back inside here. So during the respiration, breathing in, the drum will be going down while the pen will be going up. So we'll have a recording like breathing in out, and the recording will be like going up and down like that. Okay, we're going to now start with the demo. We're going to get the tidal volume and also forced expiratory volume. Okay, so the subject will need to put on the mouthpiece as well as the nose clip. Okay, so now the latch is actually set at atmospheric air. So there's some air from here, from down here. You can the subject is now taking. So once we are ready, then we can switch to spirometer. Okay, and then change the speed to 2.5 millimeter per second. So we can see the movement. So during the inspiration, the pen, it will be going up and down, up and down. So this is the normal breathing. We requested the subject to breathe normally, okay, to get the tidal volume. Okay, so I'm going to ask the subject to do maximum inspiration and also maximum expiration. Whenever you're ready, take maximum inspiration and maximum expiration. Okay, this is still the normal breathing. Okay, in. Okay, good. Out. Okay, normal maximum expiration is done. Okay, continue with normal breathing. Okay, so we're going to proceed with FEV1, which is forced expiratory volume. So the subject will be taking maximum inspiration and then hold while I change the speed to higher speed, and then we want to measure the volume that is expired in 1 second. Okay, whenever you're ready, take maximum inspiration, then hold. In. Okay, hold. Okay, blow all the way out. Okay, so this is how to measure tidal volume. We just take the height of each. So maybe we can take 3 different height of the normal tidal volume. Okay, so because it's stated here, the capacity is 1 mm equals to 30 ml. So for example, tidal volume 0.9 cm or 9 mm, so it equals to 270 ml of tidal volume. So this is the inspiratory reserve volume, the maximum inspiration. So IRV captured here is actually 3.5 cm, so equals to 35 mm. So the volume of IRV is 1050 ml, and this is the ERV. Okay, 750 ml. Okay, and for determination of FEV, is actually we want to find out the forced inspiratory volume in 1 second. So just now the speed I'm using is 20 mm per second. So this is normal breathing, maximum inspiration, followed by holding the breath. So once the subject start to breathe out or then we measure for 1 second. 1 second is 20 mm. Okay, so we want to find out the volume of this expiratory over the total volume. Okay, so this volume is stated here. Okay, it's stated here 66 mm divided by 88, the total volume 88 mm. Okay, so then we can get the percentage. FEV in 1 second is 66 divided by 88 times 100%. Okay, so that is the FEV. So for this subject, I think we are getting 75%. Okay, next we're going to proceed with the effect of excess carbon dioxide. So this one, the setup will be like the subject will take air from the spirometer. Okay, so then the expiration air will be going back inside here itself. So it will not be going to the soda line like previously. So after some time, the subject will consume some of the carbon dioxide which is inside the spirometer itself. So that is what we want to see at the beginning of we want to see the respiration rate at the beginning of the experiment, and also to compare with the last after the effect of carbon dioxide, because the subject will feel like difficulty in breathing. Okay, we want to see how the respiration rate differ from the previous one. Okay, so now start. So for this one, subject will breathe normally. I'm going to change the speed to slower speed. So once the subject feel having difficulty, meaning the effect of carbon dioxide already happened, then only we can observe the tidal volume during that time. Okay, so this is still the normal breathing process. So this is the result of the excess of carbon dioxide. So you can see in the initial recording, okay, we capture around 30 seconds. So during the 30 seconds, we can count that the respiration rate or the frequency of breathing is actually around 8.5 cycle. So if we are to get the respiration rate per minute. So it will become 8.5 times 2, that is 17 cycles per minute. Okay, so comparing that to the later stages where the excess of carbon dioxide has occurred, whereby subject has already been having difficulties in breathing. So you can see the frequency has increased to 24 cycles per minute. Apart from frequency, difference in frequency, we can also see or observe the volume of tidal volume has become greater or increasing during the effect of carbon dioxide. Okay, so next we're going to start with the determination of energy used at rest. So this is the subject weight and height. So please jot down because you will need to calculate later on. Okay, so what I have been doing is that I already mix in oxygen, 1 liter of oxygen. So we have one line here. This one is before mixing. So after adding 1 liter, the amount of volume is actually increased here. So it's going down. Okay, so after some time, the subject will consume. We want to find out the time. We want to find out the time that the subject finish off that 1 liter of oxygen. So assuming that once the subject breathe in, once it reach out of this line, then we stop the stopwatch and find out the time that the time that the subject uses that 1 liter of oxygen. Okay, so maybe we can start with the stopwatch. So this one I'm going to use the slowest speed. Alright. Okay. Now, okay, so the stopwatch has started. Okay. So we're going to monitor here. You can see the line is like going up and down, up and down. Okay. So okay. So now we can see that the reading is coming up to the baseline. So once it reach once it cross the line, then we can stop and then take the time. So this is the time, 3:33. Okay, so the time that we got is actually 3.3 minutes. Okay, so please jot down. So later on for this part, we will need to calculate. Okay, calculate energy use. Find the energy use in kilojoule per hour per millimeter square surface area.
So hi everyone. So for today I'm going to show you how to conduct experiment number 4, going to record the thoracic movement when performing the different activities. So for this experiment, actually we're going to use the BioPAD system. So we're going to connect this one we call as the respiratory transducer. We're going to connect directly to our chest area, and then for this one, we're going to connect directly to the BioPAD system through the channel number 1. This is channel number 1. And then after that, when we are doing the several activities such as breathing in, breathing out, the monitor here will be recording. It will be showing the recording part of the breathing, such as breathing in and also breathing out. So for the first part is calibration. So for the calibration part, the subject normally needs to do breathing in, also breathing out normally for 2 times. So you can click calibrate. So for the next stage is going to do a normal breathing for 15 seconds. So normally the subject need to be seated for 15 seconds and do a normal breathing. So you can click record to record. So for the next activity is the subject needs to do the hyperventilation, which is you need to breathe rapidly and deeply for at least 30 seconds. So you can click resume. Okay, so for the next activity, the students need to do the hyperventilation activity, which is need to breathe slowly and shallowly through the mouth for at least 30 seconds. So you can click resume to continue the activity. So for the next activity, the subject needs to take a cough for at least 2 cycles, and then they need to continue to breathe aloud for at least 60 seconds. So first, you need to click resume. So you need to after that, after taking a cough for 2 cycles, and then you need to read aloud. So for example, you can just read your manuals for at least 30 seconds. So experiment 4, recording the thoracic movement, blah 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 blah. For the analyzing part, you can refer to your manual. Actually, we have the lesson number 8, respiratory number 1. So you have a few tables. We have table table A for the normal breathing, and then we have table B for the comparison part. So this one you can compare the different segment. We have the hyperventilation segment, hyperventilations, the coughing part, and also the read aloud. So from here, actually you need to record a few things such as the delta T, which is the duration for each segment, and also for the BPM part. Okay.
This is the overall result. So we have the first 20 seconds is normal breathing, hyperventilation, followed by hypoventilation, coughing, and reading aloud. Okay.
So this is the first segment for your first activity, which is the normal breathing. So from here, you can refer to your manual. So your manual requires three best cycle from your first activity. So you can choose 3 best cycle, and from this 3 best cycle, you can highlight a few things such as the delta T and also the BPM. So for the first cycle, for example, you choose this cycle, so you can highlight the whole cycle, and from here you can check the total durations and also the BPM. Okay, so from here you can record the recording for each different cycle. Hi everyone, so for the next experiment, we are focusing more to the experiment number 1. So as we can see here, experiment number one actually we are normally using the spirometer, but we have one small part for this experiment. We are using the BioPAD system. You can see here at the lowest area here, we are using the BioPAD system, and this one we can use the lesson 13, which is the pulmonary functions number 2. And then from here we're going to connect the BioPAD system directly to the transducer. Okay, and then the transducer will be connected to the bacterial filter, and then the subject need to be place the mouthpiece directly to the mouth, and need to apply the nose piece as well. And for this experiment, the subject needs to do the several activities. So the first one is you need to do the normal breathing for 3 cycles, and then after that you need to record the FEV, which is the subject need to do the deep inhalation and also deep exhalations for at least 3 seconds, and then after 3 seconds of deep exhalations, the subject need to do the breathing for normal for 3 another cycles, and then we can stop the process, and then we can highlight the 3 seconds of FEV after we finish breathing. So for this table, as you can see at the page number 23, this is the data calculation for your report. So here we have 2 different areas. The first one is for the vital capacity. So from here actually you can calculate each individual FEV based on each different time that you have here, which is 0 to 1 second, 0 to 2 seconds, and also 0 to 3 seconds. So when the subject is ready, the examiner need to click the record FEV here, and then the subject need to be aware about each of the different steps. This one, okay? So you can click record FEV in 1, 2, 3. Okay, now we are done. You can click stop. So as you can see here, we have the 3 seconds of deep exhalations. So you can click the eye icon here, and then you can highlight 3 seconds. So it should be at least 3 seconds. So you can see here at the delta T, this one is more than 3 seconds already. So you should be highlight starting from here until here. So it should, the value should be more than 3 seconds. Okay, so after you're done, you can click calculate the FEV. So this is your FEV value. So for the data analyzing part, we need to refer to this graph. If you can see, we have the duration area here, which is from 0 to 1, 0 to 2, and 0 to 3. So the first thing you need to record is the vital capacity, which is from 0 to 3 seconds. So you can click the I bin, and then you can highlight the area which is from 0 to 3 seconds, and from here you can read the P2P value, which is 2.038 liter. And then after that we're going to do separately, which for 0 to 1 second, 0 to 2 seconds, and also 0 to 3 seconds, and you can record your data in your manual. Hi everyone, so then for the next experiment is actually next experiment number 5. We're going to do the collection of aspirated air by using the Douglas bag. So this is the setup for this experiment. We do have a dry gas meter. So the dry gas meter is used to measure the amount of air that we collected inside the bag. So as we can see here, we have the tube that connected directly to the mouthpiece here. So the subject need to perform a normal breathing, and all the aspirated air will be collected directly to the Douglas bag. So after we finish the experiment, the air from the Douglas bag will be transferred directly to the gas meter by this inlet. Okay, so from here we can have the total amount of aspirated air for the subject. Okay, so when subject is ready, we're going to ask the subject to breathing normally for 3 minutes. And as you can see here, the tube is directly connect to the gas meter, to the Douglas bag here. And after 3 minutes, all the collected air will be transferred directly to the dry gas meter. After 3 minutes, you can see the changes in the size of the Douglas bag. And then after that, we need to connect the tube directly to the inlet side of the gas meter, just to transfer the gas directly to the gas meter. And make sure that the tube is like connecting together we need to change the side for the tube, and then after that we need to press the back to transfer all the air to the dry gas meter. And you can see that the volume for the gas meter is already increased and keep increasing. And what you want to record is actually the total volume of aspirated air after 3 minutes. So you need to keep pressing the back until it's totally empty. Okay, so now we can get the total volume of aspirated air for 3 minutes. So this one is for the first activity, which is the normal breathing. So we're going to proceed with the same things, but for this time going to ask the subject to like running on the spot while breathing into the Douglas bag. So this is the condition of the bag after the second activity. So as we can see, the volume of the air collected for the second activity is like higher than the first one. So after we finish, we need to connect the tube directly to the gas meter. And then going to do the same thing. We need to pressing down the bag, and then we're going to see the volume of the air collected through the gas meter. And as you can see, we expected that the volume should be much more higher than the previous one. Okay, so this is the final reading, 78.8 liter. Now we're going to proceed to the experiment number 6, which is we need to measure or flow force aspiration by using the peak flow meter. So here we have the peak flow meter, okay, and also we do have the mouthpiece as well. Okay, so first we need to make sure that you need to connect the mouthpiece to the peak flow meter like this. You need to lower down the pointer to the 0. Okay, make sure that it should be at the 0 like that. Okay, so what you need to do is you need to inhale as deep as you can, and you need to blow into the peak flow meter to measure your FEV. Okay, so you need to inhale first, and then you need to place your mouth at the mouthpiece, and then you need to blow as hard as you can. Okay, so you need to do it 2 times, and then after that you need to record the average result. Okay, so you need to do it 1. So this is the first result, which is around 540. Okay, it's 1540. And then we're going to repeat the same thing. Then you need to lower down the pointer, take the deep inhalation. So we're going to have the second result is 550. Okay, so you need to record these 2 results, and you need to calculate the average for your own FEV.